in this video. Hello everybody and welcome to the 68th video on my channel. Another advanced geometry / trigonometry video. Today is actually going to be really basic and tomorrow we're going to expand on a little more, so this video is going to be really short. Please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. Without further ado, let's move on to the lesson. Today's lesson will be about a little bit of coordinate geometry and doing the basics of each of the translations: reflection, rotation, translation, and dilation. So what we want to do is we don't exactly have to label it, since this is going to be a more visual representation and the next video is going to be more algebraic. So let's draw a small shape, like maybe a rectangle. Here is a rectangle, and we're going to be covering each of the transformations in a little more detail next time, but here's the basic. Now, this is not really advanced trigonometry / advanced geometry level, but I think when we talk about it more in the next episode, in the next video, it's going to make a lot more sense and could help with proving theorems. So, let's start with translations. This is if we're moving it up, down, left, or right, or any combination. So what we'd say is if we have a point, let's say Q at position 5, 2, we would say 5 plus delta x, 5 plus 2 plus delta y. Now the reason this is 5 plus delta x is because we're changing it in x and we're changing it in y instead of just moving it. So if we have a point x1, y1, the general translation would be x plus delta x, y plus delta y. Now for reflection, what we do is we have to choose which axis we reflected on. If we reflected on the x-axis, x1, y1 becomes x1 negative y1, and that's about it. But if we reflected across the y-axis, it becomes negative x1, y1. And yeah, that's about it for reflections. Now rotations is the hardest one, as it's a little more confusing. So we're gonna do this with an example of 1, 0. If we want to rotate this 90 degrees, if we want to rotate this 90 degrees, this will become 0, 1. And if we rotate that 90 degrees again, that's going to become negative 1, 0, and so on. So what we do with these rotations is quite simple. What we're trying to do, what the formula is actually quite simple. What we have is x1, y1 if it's a rotation, and this becomes negative y1, x1 for counterclockwise, and for clockwise it becomes y1 negative x1. And then for dilation, this is really more of the shapes, and you're just multiplying the side lengths by whatever value it is, everything. So yeah, I think that's about it. Thank you so much. See you in the next one, and bye-bye.